Okay, so you're here because you really want to get a handle on distributed caching in microservices. And you want to do it right
For sure.
without spending weeks digging through like a million articles and docs.
Definitely.
So consider this your fast track.
Absolutely.
We've been going deep on building a rock-solid caching strategy.
Yeah.
And today we're going to zero in on how to strike that balance between crazy speed and keeping your data consistent when it's all over the place across multiple servers.
Right, it's like this constant balancing act, right?
Yeah.
You want things to be blazing fast for your users,
Yeah.
but you don't want them to see like outdated information.
Right, exactly.
That's the core puzzle we're trying to solve.
It's the challenge.
Yeah.
Right? So our sources are really pushing this two-tier caching system.
Yes.
Why is that? What's the main benefit of having both?
I think what's really cool here is how it uses like the strengths of different approaches.
Okay.
It's like imagine you have this super fast notepad
Okay.
right there next to you. That's your local in-memory cache.
Okay.
Something like Caffeine, if you're using like JVM services,
Yeah.
it handles all those like super frequent lookups instantly.
Okay.
And then you've got this like more comprehensive library
Okay.
nearby.
Yeah.
That's your distributed cache.
Right.
Like Redis.
Got it.
This holds way more data.
Okay.
And it makes sure everyone on the team is seeing the same information.
So local is for speed.
Exactly.
Distributed is for consistency.
Consistency, yeah. And like if that notepad doesn't have the answer, you just quickly pop over to the library,
Right.
check it out, and then jot it down on your notepad for next time.
Perfect.
Makes sense.
Yeah, so the local cache gives us that like immediate boost, and then the distributed layer makes sure everybody's on the same page eventually.
Precisely.
Okay, now where you put these caches seems to be really important.
Yes.
Strategic cache placement came up a lot.
It did.
So tell us about that.
You know, it's like placing water fountains where people get thirsty most often.
Okay.
So for services that get read a lot, you know, putting a cache right at the API gateway,
Okay.
the entry point,
Yeah.
can massively reduce the load on your back end.
Yeah.
And that's request path caching.
Okay.
But for things that don't change much,
Right.
like a list of countries or something,
Yeah.
embedding a cache directly in the service gives you super low latency.
Got it.
And then there's near cache,
Yeah.
which is a pretty clever way to keep that frequently accessed data very, very close,
Okay.
aiming for that sub-millisecond access.
Wow.
Even if the updates, you know, take a tiny bit longer to sync across all the instances.
Okay, so we're caching data everywhere.
Right.
How do we make sure it doesn't go stale and like break everything?
This is where the art of data consistency management comes in.
Okay.
So the simplest approach is setting a time to live, or TTL.
Okay.
Like you tell the cache, hey, this data is good for 5 minutes.
Right.
After that, go grab a fresh copy. But for more dynamic data, we use event-based invalidation.
Okay.
So when the original data changes, an event is sent out, like a little notification.
Yeah.
And any cache holding that data knows, hey, I got to refresh.
So that sounds way more responsive than just waiting for a timer.
Absolutely.
The sources also mentioned write through and cache aside.
Yeah.
What's the quick difference?
So write through,
Yeah.
imagine writing in your notebook and then immediately making a copy in that central library.
Okay.
So for critical data,
Right.
it ensures the cache is always up to date.
Got it.
But cache aside is more common.
Okay.
The application checks the notebook first,
Okay.
and if the info's not there, it goes to the library, grabs it, and jots it down.
Yeah. Okay.
And optimistic locking is how you handle it if two people try to update that library at the same time.
Right. Okay. So what happens if our caching system like hiccups
Oh, yeah.
or goes down completely?
Right.
That seems like a recipe for disaster in a distributed world.
For sure. Resilience is key.
So how do we make sure that doesn't happen?
So circuit breakers are like a safety switch.
Yeah.
If the cache service is having problems,
Yeah.
they stop your application from constantly trying and failing,
Right.
giving it a chance to recover or fall back to the database.
Okay.
Bulkheads help isolate issues.
Okay.
So one failing cache doesn't take down everything.
Right.
And cache warmup is like preloading all the essential books into your library before opening day.
Okay.
You don't want to get swamped with those initial requests.
Makes sense now that the sources kept pointing to Redis Enterprise
Yes.
and Redison. Why those tools specifically?
So Redis Enterprise is often favored because of its ability to form these robust clusters,
Okay.
which is super important for keeping your cache available and scalable in a distributed world.
Got it.
And then Redis, which is a client library, offers these ready-made tools like distributed locks, which can really simplify managing access to that cached data.
Right.
And Redis Streams is a good fit for handling those event-based invalidation notifications.
Right. Okay, so we've got the system in place.
Yeah.
How do we make sure it's actually running well?
Yeah.
Any quick tips on performance tuning?
So intelligent cache key design is crucial.
Okay.
Think specific, but not too specific.
Okay.
So you can retrieve related data easily.
Right.
And you want to avoid what's called a cache stampede, which is where like tons of requests hit the back end all at once when a key expires.
Okay.
Using something like protobuf for encoding data instead of JSON can also really speed things up.
Got it.
And reduce data size.
Okay.
And you can even use Redis to implement rate limiters to protect those downstream services from being overwhelmed.
So last thing, how do we know if all this is working right? Like, what should we be keeping an eye on?
Observability is key.
Okay.
You need to track those cache hit and miss rates.
Okay.
That tells you how often the cache is actually being used. Keep an eye on memory usage. How often data is being evicted from the cache.
Okay.
Set up alerts for any like unusual behavior.
Got it.
And use distributed tracing to see how that cache is impacting the overall time it takes to handle like a user's request.
Okay, so big picture.
Yeah.
It's a layered approach. We've got local and distributed caches.
Right.
Placed strategically.
Yeah.
Kept consistent through all these different methods.
That's a technique.
Built to be resilient.
For sure.
Using the right tools.
Absolutely.
Constantly tuned.
Yeah.
And always monitor.
Always watching.
It's a lot.
It is, but it's all about understanding the specific needs of your applications.
So for you listening right now, think about your own systems. What's one area of distributed caching that we talked about today?
Yeah.
Maybe it's the two-tier approach, or how you handle consistency, or even just like better monitoring that you think can make the biggest difference right away if you focused on it.
That's the question.
That's something to really consider.
For sure.
Thanks for joining us on this deep dive.
Yeah, thanks for listening.
Catch you next time.
See ya.